Okay, guys, welcome back. We are doing the second half of the chapter 11 review, number 8. Consider the following problem. Certain concrete company deposits 3,000 at the end of each quarter. Okay, wait, just stop right there. Already in that first phrase, I already pretty much know what's going to happen. We have quarterly deposits, right? The deposit is every quarter. Just from that information alone, I'm guessing it's going to be 4A because we know the periodic payment. It doesn't sound like a loan with that first, because this is deposits, right? Not you're not paying back a loan. Of course, I'm going to read the rest of the question to make sure, but let's just. But my intuition tells me 4A probably. Okay. Anyways, they deposit 300,000 each quarter into an account paying 9% interest compounded quarterly. What's the value of the account at the end of 7.5 years? Okay, so we want to know the future value. We have multiple payments. That's going to be 4A like we suspected. Periodic payments. We know the periodic payment. We want to know the future value. That's the ordinary annuity, 4A. 2,000, 9%. And quarterly means N is 4. T is for 7.5 years or 7.5. And we get 126,585.79. Yep. Matches what we expect. Number 9, we've done this before. Sebastopol. I think this question was on the last homework you had actually here. They will need $120,000 in 5 years to replace the seats. What deposit should be made today? This is a one-time, right? Into an account that pays 0.6% compounded semi-annually. Compound interest, one-time deposit. How much do I put in today? That's 2B. The compound interest present value formula. And I kind of had this 120,000 in there already just by chance. R is 0.6%. N is equal to semi-annually means 2. And this is 5 years from now. So 116,458.69. Perfect. All right, number 10, consider the amount of simple interest earned. $1,000, 5%, 7 years. Simple interest means, why don't we use the simple interest formula? That's 1A. What's the formula? I is equal to PRT. You can see it right here, yeah. I didn't actually copy all of them down, but yeah, for those where you don't have it, just refer to your formula sheet and just copy down the formula, the letters for this first box, yeah. Give the formula where I is interest in dollars, P is the present value, R is the annual interest rate, T is the time of years. So all the stuff we learned already. Anyway, what are the actual numbers? P is 1,000, R is 5%, T is 7 years, and we get 350. So yeah, all those things match up with what I have over here. Remember, guys, when you take the actual test, this is kind of what you're going to be doing, right? You're going to state, you don't have to write the formula out, but you should state which formula reference number it is, individual variables, and then give the answer. Okay, number 11. Consider the future value of the following. Okay, so then they want to know the future value. It's pretty clear what it's going to be already. We have compound interest, compounded quarterly. And this is just a single time, 585. That means it's going to be equation 2A, compound interest, future value. And it's not continuous compounding. It's just regular compounding. T is 585, 5.5% interest. Quarterly means N is 4 for 6 years. We should get 811.89. Same variables here. The formula is right there for you. Right there. Right there. And if you forgot, just check your formula sheet. Yeah. Okay, number 12. Find the future value using the future value formula and a calculator. No, this says continuous, compounded continuously. Continuously means it's going to be one of the threes. And since I want the future value, that's the equation 3A. The P is 119,200. The rate is 8.5%. And T is 20 years. So, nice. You get $652,494.53. Okay, just two more. All right, number 13. Find the present value using the present value formula and a calculator. And this time we have simple interest. So simple interest, present value means it's going to be 1C. Yeah. A is 4,000. That's what we're targeting to get 4.5%. And this is in 3 years. That 3 is right here. See, it says 3 years. So I should deposit $3,524.23. All right. Very last question, although it's kind of like several questions in one. Okay, just a moment. Sorry, guys, I had a distraction. I forgot where I was. I'm just gonna start question number 14 one more time. So it says if $12,000 is invested at 4.5% for 20 years, find the future value if the interest is compounded in the following ways. And then it says annually, semi-annually, blah, 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 blah. So this is a one-time deposit, right? One-time investment. That means it's going to be equations 1, 2, or 3. And in the first, let's see, A, B, C, D, E, F, those letters, we have compounding at some rate, right? Some annually, semi-annually, etc. So for all those cases, it's compound interest. And we have one-time deposit. We want to know how the future value. So all those indicate we're going to be using formula 2A. The P is 12,000, just starting with, right? The rate is 4.5%. Skip N for now. T is 20. And N is the one that's, excuse me, N is the one that's changing with each letter. So annually means N is 1. So there you go, to 28,940.57. Semi-annually means N is 2. And click off to update the number, and there it goes, matches. Quarterly means N is 4. That matches. Monthly means N is 12. There you go, still matching. Daily means N is 360. Remember, we use the calendar year for finance, which is 360 instead of 365. And right there, we got the same number again. Every minute means N is 525,600. And there you go, matching one more time. Next letter G says continuous compounding. So continuous means we're using a new formula now, formula 3A instead, but the same parameters. 12,000 is the P, R is 4.5%, T is 20 years, and boom, there your number is. Notice, by the way, it actually made no difference from compounding every minute to compounding continuously. Rounding to the nearest cent turns out to be the same either way. No, maybe if you look past the cents, you might get a different number, but it's basically saying compounding every minute is just about as good as continuously. Of course, that's for this particular value. You might be off of a few more cents if you had a larger number that was invested. Anyway, last one, simple interest. Let's use the simple interest formula then. And we're looking for the future value. So it's going to be 1B. Same number as 12,000 at 4.5% for 20 years. And you get 22,800. Okay, so that's it. Did the whole thing. All right, guys, let me know if you have questions. Otherwise, good luck. And I will see you soon.